Hello, students. We're jumping into division. So just a quick reminder on place values. Now, some of you might be watching these videos straight through and some of you not, but just to remember place value wise for what I'm doing, I have white chips. They're my ones. Reds are my base group. You can think of those as 1 zeros. So white, red, blue, then green, then purple, and finally orange at the very top end. Okay, well, let's do some division. I'll let you pick the base. Base 7. All right, base 7 it is. All right, so here we go. As we're doing the division, there are two main ways to think about division. And let me just lay this down so we don't get our place values mixed up. We'll be just fine here. So two ways to think about division, and we'll start small. We'll work our way up. So what I'm going to do is we're going to start with base 7. We're going to do 4, 3, base 7 divided by 2, base 7. Okay, so we're dividing by 2. All right. So what I would do is if I want to do this with the chips, I'd make 4. I'd have my 4 reds. There they are. And I would want 3 ones. There we go. So there's 4, 3. Now I'm going to divide by 2. So there's a couple ways to think about this problem. And this is a good way to approach it with your students as well. One way is to say, I want to divide by 2. So I want to make 2 groups. Okay. And the question we're going to ask is how much is in each group? Now, the reason why this is a really nice one to try at the beginning is that if you're dividing into 2 groups, you really can just take all of your chips and make sure that you kind of in each group, you are fair. So there's one group and there's another group. I give 1 red each. Then I put 1 here and 1 here. See how that's fairly distributed? And I'm all out of red chips. So I'll come over, grab some white chips, and I'll put 1 and 1. And I got this 1 left over, but it really, if I put it in either one of the groups, it's not fair. So my final answer, if I was to write this out, would be each group has 2 reds and 1 white, which would be 2, 1, base 7. And what's left over turned out to be just 1. So I had 1 chip left over, remainder 1. Okay. So that's one approach, right? So again, that approach works, like I said, works really nicely. Could you get some regroupings? Absolutely. So for example, if I had 5, 5, base 7 divided by 2 base 7, then so again, if I make my 5, there's 4, 3. So let's see here. There's 5 and there's 5. So now I have 5, 5. But if I was doing 5, 5 divided by 2, and I think to myself, I want to make 2 groups, then I would start kind of putting them into 2 separate groups, group 1 and group 2. And I would be swapping these in there, and I'd feel pretty good about that. Okay. Now I have 1 red left over, which is kind of a problem because I'm trying to make these into perfect groups of 2, but I only have 1 of them. So what I can do is come off to the side and say, well, wait a minute, bank. Can you just give me some extra white chips for that red chip? And they would say, sure, you're in base 7. So I'm going to give you 7. 1, 2, 3, 4, 5, 6, 7. There's 7 white chips. And then you could just start doing the same thing. You could make those into 2 groups. So 1 apiece, another 1 apiece, another 1 apiece. I got a leftover here. Oh, but I have some extras that I already had. So let me put those all together. And it actually worked out totally perfect this time. Each group had 2 reds and 1, 2, 3, 4, 5, 6 whites. So my final answer here would be 2, 6, base 7. And I don't need to write a remainder because it went in perfectly. Okay. If you want to check yourself, make 2 groups of 2, 6. So 2, 6, here they are. There's 6 of those. There's 6 of those. So I have a 2, 6 and a 2, 6. Which is perfect. And then I'm just in base 7. So there's 6 plus 1 gives me 7. And at the end of the day, I would have 1, 2, 3, 4, 5 whites and 1, 2, 3, 4, 5 reds, 5, 5, which is the amount I'm supposed to start with. So it checks. Okay, so like I said, this is one approach. I make two groups. That's making two groups. But you don't have to make two groups. The other approach would be to make groups of two. And this is a different mindset. Let's see. So what would that look like? These are like glowing now. That's okay. That's kind of cool. Makes it look like they're gold. They're not really gold. Oh, that made it even brighter. Okay, forget about it. So let's see here. I want to make actually two groups. Let me go back to the first problem. 4, 3. Okay, so I'm going to start with 1, 2, 3, 4, and I'm going to make 1, 2, 3. So 4, 3. Now, instead of thinking of dividing it into two groups, I'm going to make stacks of 2. 2. So right here, this is a stack of 2. Okay. These other ones, these are worth 7, so they're not really 2s. So I could think, oh, okay, I'm going to go over here and I'm going to regroup these. So if you do go over and regroup, remember each one of these gets 7. 1, 2, 3, 4, 5, 6, and 7. So you want to kind of make some, and then you're going to be kind of swapping out. So there's one of them going off to the side, and I still had one left over. So I'm going to take one of those chips and I'm going to get 7. One of the reds, I'm going to get 7. One of the reds, and I'm going to get 7 white chips, and one more of the red, I'm going to get 7 white chips. Okay, so I have a whole bunch of stacks here, but remember what I'm making is I'm making groups of 2. So I basically take stacks of 2 and I count them up at the end of the day. So that's what I want to do. Stacks of 2. There sure are a lot of them. Okay. 2, 2, 2, 2, 2, 2, and I kind of have one left over here. Okay. Phew. Okay, well, let's see here. How many of these stacks of 2 do I have? Well, I have 1, 2, 3, 4, 5, 6, 7. So let me kind of separate those. 3, 4, 5, 6, 7. Okay, there's 7. And then 1, 2, 3, 4, 5, 6, 7. Okay, 6, 7. My green chips are kind of getting in the way. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And then I have one additional group of 2 right here. So every group of 7, if I was counting, that's 7 plus 7, that's 14, 15, and 1 left over. And if I think 15, I would write that as 2 groups of 7 and 1 remaining. That's 15 with a remainder of 1. So we get the exact same answer. It definitely takes a little longer to make all these 2s. But you could also say, well, wait a minute, if I kind of put all these back together the way it was initially, this is where the thinking slightly differently does pay some pretty big dividends. Let's start again with the 4, 3. And I want to show you the thought process and kind of bring in what we did with multiplication, because multiplication is our friend. And so what I have here is I have 4, 3, and I want to make groups of 2. So every time I can make a group of 2, I'm in a good shape. So if I do this, definitely I see that's 2 white chips. That's a group of 2. But what we did with multiplication is we looked for things that looked like this that were moved up 1 place value, and that was just a slightly higher place value. So I make groups of 2 at the next place value. Okay, so I'm stacking those up to make a 2, a 2. This is a 2, and this is what's left over. So I have 2 groups in this place value, 1 group in this place value, and 1 left over. So 2, 1, remainder 1. Okay. If I was doing 5, 5, that's this problem here, 5, 5 divided by 2. So I would start with 5 and 5. 1, 2, 3, 4, 5. 5, 5 divided by 2. Okay, so again, I'm going to make groups of 2. So I'd make, there's a group of 2. There's a group of 2. And I don't have enough to make another group of 2 with this, so I can swap it out. 4, 1, 2, 3, 4, 5, 6, 7, because I'm in base 7. And then I make all my 2s here. Okay. And what I can see is I make 2 of this group, 6 of this group. So my answer is 2, 6, base 7. Right. Let's make some other stuff. So instead of just dividing by 2, right? Let's make some other stuff. And here we go. Let's try something that looks a little bit more complicated. So let's do a 3, 1, 4, base 7, because that's like pi, right? 3.14. So 3, 1, 4, and I'm going to divide by some 1, 3s. Okay. Base 7. Okay. Oh, let's see here. All right. So if I'm looking at this number, 1, 3 right there with base 7 means I have a group of 7 and 3 1s. That means I'm making, you could think of it as making groups. So I'm going to make 10 groups. Okay. So if I was making 10 groups and they all had to be the same size, I would need to break these up at times to make 10 total groups. Okay. So if I was looking at this, I would have 3, 1, 2, 3 blues. I would have 1 red and 4 whites. Okay, so 3, 1, 4 is what I start with. Now I want to make 10 groups. All right, well, there's nothing wrong with making 10 groups, right? We can do that. Each one of the blues, I just don't have enough blues to make 10 groups with the blues, so I got to do a little swap in here. Each one of the blues is worth 7 reds. So what I'm going to do is I'm going to swap in my blues and get some reds. So every blue that goes in, 1 blue, I get 7 reds. 1 blue, I get 7 reds. 1 blue, and I get 7 more reds. So now I have 3 stacks of 7, which is quite a bit, and an extra 1 here. Okay, well, let's try this. I'm going to make 10 total groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There's 10 groups. Okay, well, let's see. Maybe I have enough for another one, so I'll put 1 more in each group because I want to be fair. I want to be fair, so I want each group to have the same number in them, and I got a couple of these pieces left. I don't have enough to make another one for each group, so I swap these in. Remember, each one of these is going to be swapped out for 3, 4, 5, 6, 7. That is correct. I need to get 7 whites. So there's 7 whites in exchange for 1 red. Here's 7 more whites in exchange for 1 more red. Pick up all of your white chips and then begin distributing them onto each pile. Remember, we have to make 10 piles. And I wish I could go on, but I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 remaining. That's not enough to put another stack on each pile. So now I take a look at any of the piles because they're all the same. My pile has 2, 1 in it. So my answer would be each pile has 2, 1, base 7. And I have a remainder over here of 1, 2, 3. 1, 2, 1, 2, 3, 4, 5, 6, 7, and 1. So I could actually regroup this. 1, 2, 3, 4, 5, 6, 7. 7 of these would be the equivalent to 1 of these. This is 7 and 1, which is a remainder of 8. And so I would write that as a 1, 1, base 7. Okay. It's just not enough. I only have 8 left. I needed to make 10. So this is the approach if you want to make groups of a particular size or a certain number of groups. In this case, I was making 10 groups. Totally fine to do that. And then you can see it's kind of fun. Actually, the kids, when you do this with kids, they will actually be putting chips into piles and they're like, got it, that's fair and no issues. Let's try the other approach with division because that's going to be a whole lot quicker. as we keep going on. So what I'm going to do is I'm going to restack all of these if I need to. All right. So now here comes the fun part. At least for me, when I'm looking at this, I look at 1-3s and I remember a 1-3 looks like this. But that's if I'm making them in the lowest place value. I could also make a 1-3 that looks like it's been shifted up one place value. So I want to look at things that are a chip and then 3 chips that are less than that, and that would be groups of 1-3. Okay, so that's what I'm looking for if I'm making these. I'm making 1-3s and I can make them in any place value. Let's start again with 3, 1, and 4. There it is. I want to make things that look like 1-3s. And so I could make the red with 3 of these and make a 1-3 right here. I could, but if I can make larger groups of 1-3, that's better. So what I'm going to do now is I'm going to take one of my blue chips and try to get a few more reds here. I want to do it fairly. So one blue chip is worth 7 red chips. So I now have 7 additional red chips. And what I'm going to do is I'm going to make groups that look like a 1-3. So 1 of this with 3 of the next piece. 1-3. 1 of these with 3 of the next. So there's my stacks of 1-3. Notice I have a couple chips left over. That's great. And so I'm going to take a 1 of these and 3 of those and put those together. And I have something left over at the end, which is a 1 and a 1. So if you take a look, in the 1 place value, I have 2 of these. In the smaller place value, I have 1. So my answer would be 2, 1, 2, 1. Remainder of 1, 1, which would be 8. And there we go. Okay. How would we do this without the chips? Well, what I just showed you right here, this approach, perhaps for some of you, you're like, oh, that's still confusing. Maybe for some of you, you're like, oh, I can see that. I'm not sure. Make sure you ask questions in class if you do have other questions. But this is actually what you do when you do long division or any type of division algorithm. So when you think about 13s or 1-3s, I said 13s. God, how many times have I told y'all it's not 1-3? And I put that into 3-1-4 base 7. I fell right into it too. I was raised in base 10. Don't worry, you're not alone. So what I try to do is I try to make groups of 1-3. I try to make them out of my largest place value, but I don't have enough. So I come over now, I try to make them out of this next place value. So 1-3, it definitely goes in here. And it looks like it can go in more than once because I know 2 times 1-3 would give me 2-6 because 2 times 3 is 6 and 2 times 1 is 2. And then I just do my subtractions. And I'm subtracting in base 7. So this becomes a 2. I bring over 7. Remember, I say the word 7. 7 plus 1 is 8, and 8 minus 6 is 2. Bring down the 4. Now I have a 1-3 right here. Only one time is that going to go in, because when I subtract, I get 1-1. And so my final answer is 2-1 base 7, remainder 1-1 base 7. And you'll notice it matches exactly with what we had before. So the chips are just a way to physically get students to see the connections that we're making between the concrete examples of how do we distribute numbers, how do we break them up, and the abstract algorithms, which again have nothing to do with actual chips whatsoever. Pretty cool. All right. You wanted to try another one? Let's try another one. You want a different base this time, or you want the same base? Different base? Okay. All right, maybe we'll do base, I don't know, 8 this time. Base 8, right? So let's get a bigger number then, shall we? 2, 5, 1, 3, 7. There we go, base 8. There we go. And we're going to divide it by, what do you want to divide by? A 2-digit number? A 3-digit number? It doesn't really matter. Divide by a 2-digit number. Okay. Well, what do you feel like? Well, let's do maybe two of these. Let's do like a 1, 2 base 8. I'll do a 2-digit number, then I'll do a 3-digit number. Okay. So 25137 base 8 divided by 1, 2. So I'll do it with the chips. So I need 7. There's 4, 5, 6, 7 white chips. I need 3 red chips, 1 blue, 5 green. 1, 2, 3, 4. There's 5 green and 2 of my purple chips. There we go. And I want to make groups that are 1, 2. So every chance I get, I would take one of the highest place value possible and pair it with 2 of the place value right below it. There's a 1, 2. If I can do it again, which I can, there's another 1, 2. Now I'm left with one of these chips. I don't have enough right now to make a 1, 2. If you can see, that's like a 1, 1. So I actually have to take this green chip and break it down into blues. And it tells me each green chip is worth 8. 1, 2, 3, 4. And that's it. There ain't no more. So there's 8. So I'll take 8 and I'll trade in my green chip. Okay. Now, as much as I can, I want to make groups of 1, 2 here. So I take 1 blue and 2 reds. That's fantastic. I don't have enough reds, but I do have just an absolute glut. Look at all these blues I have. So I'm going to take a blue and trade it in for 8 reds. That's fair trading. And then I make some more groups of 1, 2. So 1 blue with 2 reds, 1 blue with 2 reds, 1 blue, 2 reds, 1 blue, 2 reds. Things are looking pretty good. There's a lot of them. I still have 3 blues left, and I don't have enough of these, so I'm going to do one more swap, trade in a blue, and pick up some more reds. That's a fair trade. I take one of these for 2 of those, and finally one of these for 2 of those. Now I am left with just a bunch of reds, and I can start making some 1, 2s. 1, 2, 1, 2. Now I've got a couple reds, and I don't have enough, but if I swap a red in, I could make some more 1, 2s at the lowest level. Let me do that. Trade a red. That gives me 8. And so I'm going to get 8 white chips for that. And that leaves me enough to do one more group of 1, 2. And then at the end of the day, I'm actually left with 1, 2, 3, 4, 5, 6. I have 7. Wow, that's huge. Huge remainder. But let's take a look at what we end up with. So these are purple green. So this is at 1 place value. The next place value I should have would be greens with blues, but I don't have any of those. So next up would be just the blue and reds. So I'll organize those so I can kind of see how many I have. And then after that would be the reds and the whites. And here they are. So looking at my place values, and then I have a remainder here of the 7 that we talked about. So place value wise, I have 2, 0, 7, 4. So my answer would be 2074 with a remainder of 7. And all of these are base 8. Okay. And that is how you can do it. All right. If you wanted to, though, you could also have done this one where 8, so 8 plus 2 would be 10, so you'd be making 10 groups of this one as well. All right, so let's toss that back in there. And let's see if we can't make some other, let's do some 3-digit divisor. Not that it, once you get the idea, it really doesn't make too much of a difference. So let's use the same dividend. We'll just use a different divisor. And let's see what we come up with. So let's do 25137 base 8 divided by, what do I want to divide by here? Instead of 1, 2, why don't we do a 1, 2, 1 base 8? Okay, I know this looks complicated because it's a larger number, but I don't think we're not gonna stress too much out about this. So I need to make a 7. 1, 2, 3, 4, 5, 6, 7. Okay, there's 7. 3 of these. 1 blue. 5. There's 5 of those, and 2 purple. So there we go. 25137. I need to make things that look like 1, 2, 1s. What is a 1, 2, 1? Take your largest place value, put 2 of the next size on it, and 1 of the next size. That's a 1, 2, 1. That's at the largest level possible. Next up, I want to make a 1, 2, 1, and I have a 1. I have the 2, but I don't have any of these blue pieces left. So I need to swap in a green tile and get myself 8 blues. And there's 8 blues, and I need 1, 2, 1. So I'm going to take a 1, 2, 1. That's 1 purple, 2 green, and 1 blue. And I'm going to set those off to the side. Okay. There they are. I made 2 of those stacks. Now I want to continue. I want to make 1, 2, 1s. So I'm going to have 1 of these, 2 of those, and 1 of these over here. 1, 2, 1. I want to make another 1, 2, 1, but I don't have enough red chips. I got enough white, I got enough blue, but I don't have enough red. So take one of your blue chips, cash it in, get yourself the base number, which is 8. Take 8 of those and make some 1, 2, 1s. 1, 2, 1s. And all I'm doing is making 1, 2, 1s because that's what I'm dividing by. 1, 2, 1, 1, 2, 1. Super fun to do. And at the end, I want to make some more 1, 2, 1s, but all I have is I have 1 of these, 1 of these, and 2 of those. That's not enough. So bring those off to the side. That's my remainder. Here's 1, 2, 1s. This is the smallest 1, 2, 1 you can make. That's a blue, red, and white. The next place value would be green, blue, and red, but I don't have any of those. And my next would be purple, green, and blue, and I do have 2 of those. So my answer would be 2, 0, 5. And my remainder is a 1, 1, 2. And all of these are base 8. And that is how you do it with chips. Now, if you'd like to see it with the algorithm, sure. 1, 2, 1 into 2, 5, 1, 3, 7. So if I didn't use any chips, 1, 2, 1, does it go into 2, 5, 1? I think it does. Let's say 1 time. This is the scaffolding approach. 1 minus 1 is 0. 5 minus 2 is 3. Minus 2 is 1. I get 1, 3, 0. Hey, I've got enough to put another one of these in there. So let's put another one of those in there. And I can just add it to the same place value because I haven't moved over at all. So one more of these is a 1, 2, 1. And then I'm in base 8, so I subtract. This gives me 8 minus 1 is 7. Okay, so I now have 7, 3, 7. Now, again, it looks like I can get at least 4 of these, right? But I could definitely do at least 3 of them. So why don't I do 3 of them here? So notice the next place value would be right here, would be 7, 3. And I don't have, 7, 3 is not enough. So I have to go over to the last place value. That's why I put a 0 here. Because if it was just 7, 3, I need to make groups of 1, 2, 1, and I don't have enough in the 7, 3. So 7, 3, 7, I don't know, I think 3 of them should work because I can multiply by 3 really quickly. There's no regrouping. So 3 times this would give me 3, 6, 3. When I subtract, that gives me a 4. And then here I need to regroup. So this becomes 8 plus 3 is 11, and 11 minus 6 is 5. So I now have 2, 5, 4. Oh, definitely, I could do more than that, right? So I could put another, oop, that's 3, 5, 4. Don't know, 6 minus 3 is still 3. I could do at least 2 more, it looks like. So I'm going to put 2 more on top of there. 2 times 1, 2, 1 would be 2, 4, 2. And when I subtract, I get a 2, 1, and a 1. And yeah, I don't have enough left over. So my final result, if I put these all into place value form, would be 2 in this place value, 0 in the middle, 2 plus 3 is 5 right there. This is base 8, and I have a remainder, bring it on up, of 1, 1, 2, base 8. And that is how you can do division with either the algorithm or with the chips. Either way. So again, that's why I really think it's significantly easier to make, in this particular case, groups of that particular piece and then just find them moved up with different place values. Yeah, I think that's about it. Let's see here. Maybe should we do one more just for fun with the chips? Okay, yeah, we'll do one more with the chips. Just a bigger thing on the divisor. Okay, so we'll do 2, 5, 3, 4, 6. I'll stick with base. I was doing base 8. Why don't I do base 7 just to kind of show it doesn't matter what base we're in. Really doesn't matter. So 2, 5, 3, 4, 6, and I'm going to divide by what do I want to divide by? 3. That doesn't matter. 3, 4, base 7. Okay. So 2, 5. So I need 2 purple. I need 5 green, 3 blue, 4 red, and 6 white. Okay, so 2, 5, 3, 4, 6. And I'm going to divide into 3 4s. So I need to make things that look like 3 4s. Unfortunately, as I start this one off, you'll notice I only have 2 of these pieces. So I normally would have wanted to take 3 and put them with 4 of the next level. I just don't have enough. So I do need to do some swapping here, and this is base 7. So I'm going to make some stacks of 7 greens because every purple that I trade in becomes a full stack of 7 greens. Every purple I trade in is a full stack of 7 greens. I now have a ton of greens, right? 2 stacks of 7 plus 5 more. That's quite a few. Now I want to make things that look like 3 4s. So a 3 of 1, so 3 greens and 4 blues, but you can see I do not have enough blues. I also have a ton of greens, so I'm going to trade at least a couple of these greens in to get a few more blues. Remember, 1 green is worth 1, 2, 3, 4, 5, 6, 7. And since I have a feeling I'm going to need a couple of these, I'm going to make a few stacks of blue. So I'm going to trade in. So I traded 1 in for that. I'm going to trade another green for another big stack of blues, and that should do it. So 3, 6, 7. Okay, what am I making? I'm making 3 4s. So that means I need 3 greens and 4 blues. So they're going to go a little bit quicker this time. So that's a 3 4. Take 3 of these and 4 blues. Okay, 3 4. Take 3 greens, 4 blues. Take 3 greens, 4 blues. I'm making great stacks here. I have quite a few greens left, but only 1 blue. So guess what? I got to actually swap another green one in for 7 more. And then I'll bring those 7 over, and I'll make another group of 1, 2, 3, and I'll make 3, 4. So I'm going to put all of those together. Now you'll notice I have a green left over, but I can't make another. I don't have enough of them to make another 3 4. So that's all I can make right here. That looks great. Let's do one more swap. A green for 7 blues, and now I have again a ton, an absolute massive number of blues. But I don't have enough reds to make everything I want. So why don't I take one of my blues and trade it in for 7 reds. And then I'll make some 3 4s. That's 3 blues, 4 reds, and just put those in a stack. 3 and 4. There we go. And then I have 3 and 3. You see that? 3 and 3. It's not enough. But if I say, okay, I have enough blues, I could trade a blue in for 7 more reds. There we go. And I can make one more 3 4. So now I'm going to put those together. That looks great. And you know what? I've got enough here. I can make a 3 4 out of my lowest level. And then I have a 3, but just 2 remaining. So I don't have enough to make another 3 4. And even if I cash in the reds for whites, I still wouldn't have enough to make a 3 4. So I leave that off to the side. That's my remainder. And so what I have in place value form, the lowest level, I have 1. The next up, I have 3. And the next above that, I have 5. So my final answer here would be 5, 3, 1, base 7 with a remainder of, and let's check it, 3 pieces here and 2 there. So it looks like a remainder of 3, 2. Base 7. So that is how we can do chip trading to demonstrate place value. And again, the poker chips are very, very handy because it could be any place value. If you are using the base blocks to do this, they'll work really well for whatever base they are cut to be in. But again, not all of them work out perfectly in that way. Okay. What's the other approach to this one? Well, the other approach would be a very, 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 very long one because 7 times 3 is 21 plus 4 is 25. So yes, you could actually make 25 separate individual piles. And if you had 25 students in your classroom, this might actually work out okay to go and give the same amount to each one. Just remember when you start with like when we start with 2 purples, right? With 2 purples, you'd have to split these up into 25 individual groups. That's not going to work really well. So even if you trade them in for 7s, right? At the 7-to-1 ratio, that's only 14. That's not enough to make it all the way around. So that's why sometimes making kind of fixing how many groups you have can make things a little bit longer. Anyway, so that's it. So as you're making these pieces, just realize that what you're doing when you do the algorithms is you're actually doing the same exact thing. You're looking for shapes, and you're looking for some multiple of those shapes. And that's why when I did say we want 3 4s, it's really, I could look for 3 4s, base 7. I could also look for 3 4 zeros, base 7. And I could look for 3 4 0 zeros, base 7. These are the things I'm looking for, because this is like a 3 4 times 1. The next one is a 3 4 times 1 0, which basically is like, instead of making individual stacks of 3 4, this is like making 7 of those groups at a time. So it saves you quite a bit of time. It's quite a bit more efficient. And this last one would be like 3 4 times 1 0 0. Okay, so this in groups of 7 would be 49. So that would be a huge number of individual piles you'd have to make. But I don't have to when I think of it as, oh, I can actually take away these things, objects that look like 3 4 shifted over to place values, and it becomes a lot easier to work with. Okay. All right. Let's see here. Do we need to do the algorithm? I guess there's probably going to be somebody who's like, can you do the algorithm? Sure. So let's do the algorithm. So if I was doing an algorithm, I'll do traditional this time. 3 4 into 2 5 3 4 6. All of these are base 7. Okay. So if I was doing this in base 7, honestly, I do not know base. I know that seems weird for me to say because people are usually like, oh, he's already knows all the answers. No, I don't know base 7 that well. I never grew up with base 7. So what I would probably do with this is I would probably say, actually, let me push these out of the way just a little bit so I get a little bit more. There we go. Yeah, you know what? I'm gonna sit out to the side and I'm gonna make a multiplication table in base 7 for 3 4. So what I would do is I'd say 3 4 with another 3 4 would give me 6 8. Basically, I'm saying, what would it look like if I had 2 of these? Okay, so 4 plus 4 is 8, but I'm in base 7, so that would be a 1 1. And 3 plus 3 is 6, plus 1 is 7, so 1 0. Okay. So if I'm thinking about 3 4s, if I had 2 of them, it would look like a 1 0 1. Let me add another 3 4 on here, which would give me a 5, a 1, and a 3. And the reason now this would be like adding 3 groups of 3 4. I get a 1 3 5. Okay, I'm going to go with another 3 4 here. Now this gets a little weird, right? Because 5 plus 4 is 9. 9 is a 7 with 2 left over. 3 plus 3 is 6, plus 1 is 7. So again, I'd bring it up here. So this is what 4 of them looks like. And if you take a look, that that's good because 2 of them was 101, so 4 of them should be exactly twice as many, should be 202. And again, this may look confusing to you, but what I'm doing is I'm making all of the multiples of 3, 4. And that way, when I do the division, I can get the exact answer each time, and I don't have to scaffold. So let me do another 3, 4 here. That gives me a 6, that gives me a 3, that gives me a 2. This is 5 groups. And I'll do one more. So I'll do a 3, 4 here. 6 and 4 is 10. That's one group of 7 and 3 ones. 3, 6, 7. 0, 1. And that gives me a 3. Okay. And that actually makes sense too, because if this is 2 of them, to get from 2 all the way down to 6 of them, you would just need to do that 3 times. So 101 would become 303. So now I have my multiplication table. When I do the division, it'll be quicker for me to do the division. So do you need to do this every time? I don't think you do. But I also find it's very helpful because right now I never have to do another multiplication as I do this. So 3, 4, does it go into 2? No, I don't have enough. Does it go into 2, 5? No, I still don't have enough. Will it go into 2, 5, 3? And the answer is heck yes, it will. Definitely once, definitely twice. 3 times are good. 4 times is good. 5 times is good, but 6 is too many. So I would go with 5 times. I'd put a 5 in this place value. 5 times 3, 4. I already know what it is. Again, that's why it's sometimes really nice to have this table already done. If not, you'd have to go up and do the multiplication, which is not bad. I mean, either way is fine. I do a little bit of regrouping. I'm in base 7, so I'd say 7 plus 3, that's 10. 10 minus 6 is 4. 4 minus 3 is 1. 2 minus 2 is 0. Now I bring it over here and I bring the next place value down, so I have 1, 4, 4. Can I get a 3, 4 into 1, 4, 4? And the answer is definitely once, definitely twice. There's 3 times. It works. Yep. And 4 times is too big. Okay, so I would say 3 times. So I put 3 in the correct place value. And 3 would give me a 1, 3, 5 because I already know what 3 groups of that look like. Subtracting gives me a 3. I bring over 7. 7 plus 4 is 11. I take away this, gives me 6. Bring this down, and I'm left with 6, 6. Does 3, 4 go in there? Yes, it goes in at least once, and twice is too big because it should be 101. So I need to put a 1 up here. It only goes in once. Leaves me a 3, 4. I'm left with a 3, 2. And so my answer is right here. 5, 3, 1 base 7 with a remainder of 3, 2 base 7. And that matches exactly what we got when we did it with the chips. Phew. Love these chips. And that is going to do it for me with my videos tonight. Hopefully this is helpful as you're kind of playing around. We'll do some more working with the chips tomorrow in class and be looking at these groups. And we'll also take a look at some additional algorithms and kind of connect the ideas of division and multiplication. I look forward to seeing you then. All right, off you go.